broken access control is one of the top vulnerabilities that's discussed on the OWASP top 10. I believe it's at number 5 out of 10, so it's a fairly common one, and it sort of lives on the same sort of ground as broken authentication in the sense that we're not properly enforcing controls that determine who has access to what resources on a system. So we're going to take a look at a few different ways that this happens and then discuss some ways to mitigate these sorts of issues. So in general, when we're bypassing access control, we're looking at modifications of things like URLs, HTML pages, maybe through APIs, application states, things like cookies, really anything that's in the user control. They may be able to modify it and in turn utilize that to be able to bypass the actual access control of an application. In general, access control is the component that after you've logged into the system, it determines what sort of actions you should be able to take. And in general, it can also determine what sort of actions a non-logged in user can take. So there's sort of two components there, either a non-authenticated user being able to do authenticated things, or an authenticated user being able to do higher level things such as administrative actions. So one way that this can happen is through primary key manipulation. So inside of a database, you'll have a primary key which will keep track of the current record of the person who's utilizing the application. If for some reason the person has access to that private key, they might be able to change it to map to a different user, which can help them circumvent access control. A good example of this could be something like student ID, for instance. So if you're on like a student system and you have a student ID, if the user can modify that student ID for some reason, then it will change how it maps to a different user and could help them circumvent access control. Another even more common one, there are some people for some reason who may use first name and last name as a primary key, which in general is a really bad primary key because it has duplicate values. But if you do something like that, you can actually potentially, change those fields if you have power over those fields, which you usually would in an application, and that in turn could map you to different users and then help you circumvent access control. So things like usernames, that sort of information is the type of stuff that might be able to help you circumvent these sort of pieces of information. Also, in general, when you send a request for like an API or a cookie, sometimes you might have to put in a primary key like a username. If you can change that username and it doesn't verify it server side, then you might be able to get access to something you shouldn't be able to get access to. So the general process of getting more permissions than you normally have is known as an escalation of privilege, and that's a very typical type of vulnerability. And there's a few different ways, as we discussed, that this can take place. We can either act as a user without logging in or escalate from user to admin without authentication. Now, one of the things that I want to discuss here is the idea of escalation of privilege from the context of an operating system. A lot of the times if you compromise an operating system, you may compromise it as a normal user. For instance, if I have a Linux box that has a whole bunch of SSH users and they're all different users in my company, for example, if you manage to brute force one of the users because they have a really bad password, your next step would be to try to escalate permissions or escalate privileges to become an administrator. So if you're able to find an escalation of privilege somewhere, then you're able to escalate your permissions and become an administrative user. This sort of thing happens a lot with applications. If you find an application and you're able to find an escalation of privilege through that application, say it's like a system level application, for instance, then you might be able to escalate yourself to an administrator without any sort of authentication. So that would be an example of escalation of privilege. And in general, things like metadata manipulation is very common. If you have tokens such as JWT, which is, I think JSON Web Token is what that stands for. A lot of the times people could attempt to tamper with that information. So if you're storing tokens on the user side, the idea is that you always should be verifying it on the server side. Same sort of idea with cookies or hidden fields. Anything that the user has control over should be validated server side. You should never trust it at face value. So different metadata things like web tokens or cookies can often be manipulated to try to find an escalation of privilege. So it typically involves things like changing a role to admin, for instance, or doing something like that will allow you to impersonate an administrator without actually being an administrator, and that would be through metadata manipulation. And then one of the big ones that's coming up more and more is everybody wants an API in their application, but a lot of people don't really implement them properly. So missing controls on APIs tends to be a fairly common problem. If you do like posts, puts, deletes, that sort of thing, you may be able to utilize these API calls without proper permissions. So maybe typically we only want an admin to delete data, but if we don't authenticate it through the API, someone might be able to delete data without having any sort of permissions. So this is a really important one to keep in mind. If you ever have an API that has external access, different things like post and put and delete and get, for instance, should all have permissions associated with them. If they can get to data that they shouldn't be able to get to without authenticating, they shouldn't be able to run that call through the API. So we should always enforce those permissions, ensuring that unauthenticated users can't get access to data or modify data without permissions. So the final piece here is to just discuss like a general idea of how to prevent access control breaks. So on default, whenever you're checking for permissions, if you run into some sort of problem, you should default to denying access. So if someone tries to access something and an error occurs, for instance, you should default to just denying access immediately. So you never default to allowing the user into the system, because that's how these sort of like escalations typically work. We want to always log the information too. So whenever someone accesses something, we should log that information. If something looks funny, like someone accessing an admin page without a username, or someone accessing an admin page that isn't an admin, that can help us see that there's an access control break without actually, having it happen, right? Well, it will happen, but we'll be able to notice it when it does happen is the idea. And then the other thing is to verify access control on the server side. We never trust user-controlled data. We should always verify everything the user gives us on the server side in a way that they do not have control over. If someone claims to be an administrator, we should make sure that they actually are an administrator. We should not let anybody be able to control that information completely. Otherwise, we're going to get into these access control breaks. So this in general gives you a few different examples of access control type vulnerabilities. It allows you to get a bit of an understanding of how these sort of things present themselves in applications. So if you ever run into these sort of instances in your own applications, you can apply these sort of steps to fix them. Otherwise, this will help you sort of look for those issues to determine if they exist on your system, to ensure that they don't happen and to ensure that they're prevented.